Good morning, students. Welcome to day 2 of Corona break. Today we're going to be covering section 10.2 in the geometry book. You'll need to write these important terms down. You should be familiar with the ones associated with a polygon. The circle, you can see I've illustrated right here. We have the circumference, radius, and diameter. Note that the radius is equal to half of the diameter. Here are the formal definitions right here. Okay, the circumference of a circle is equal to the perimeter of a circle. Okay, we have this number here called pi. It's an irrational number, and that number represents the ratio of the circle's circumference to its diameter. The two new terms for today are the apothem and central angle. The apothem is the distance from the center of a polygon to its side. The central angle is an angle with the vertex at the center and rays from the center to the consecutive vertices. This picture right here is illustrating our points, okay? There's our sides, our vertices, and the apothem. Notice the apothem will always form a right angle, a perpendicular bisector, because that is the shortest distance from a point to a line segment. Notice that our central angle, when connected to the vertices, forms an isosceles triangle. When we split that isosceles triangle in half, we get a right triangle. So, furthermore, since the apothem is a perpendicular bisector, it splits the side in half. Our right triangle will have a side equal to 1/2 of the side, and it will also have an angle equal to 1/2 of the central angle. We use that information later in the section, okay? Here are the formulas that you need to add to your formula sheet, okay? The area of a circle is equal to pi times the radius squared. The circumference of a circle is equal to pi times the diameter. The central angle of a regular polygon, and remember, a regular polygon has congruent sides and angles. So the central angle of a regular polygon is 360 divided by n, where n is the number of sides. For a hexagon, which has 6 sides, n would be 6. An octagon has 8 sides, n would be 8. Right here is the area of a regular polygon. This is the most important formula from this section. It's equal to 1/2 AP, where A stands for the apothem, and P stands for the perimeter. Remember, the apothem is the black lines in the hexagon, okay? And then the perimeter is the sum of all of the sides. Right here are exercises showing how to find the circumference and area when you're given the diameter and the radius. Now, the steps to find the area of a regular polygon, 6 steps. First, you draw a right triangle with the apothem and central angle, okay? We have problem number 15 in the book right here with an octagon. We're going to draw our central angle right here. Okay? Notice that'll give us 2 right angles. One of them, of the sides of our right angle, is equal to 1/2 the side of the polygon. Okay? Now, we find the measure of the central angle using the formula. So we'll take 360 divided by 8. That'll give us 45 degrees. Now, notice that our right triangle has half the measure of the central angle. So half of 45 degrees is 22.5 degrees. At this point, I'd like to go ahead and draw my labeled right triangle. So we have a right triangle with an angle of 22.5 degrees, 1/2 S here, and this one right here was 2 from our picture. Now we solve our triangle right here for S. Notice that this will be the opposite side to the angle. This will be the adjacent side to the angle. Tangent is the trigonometric ratio that has opposite and adjacent. So therefore, we will take the tangent of theta is equal to opposite over adjacent. The tangent of 22.5 degrees is equal to 1/2 times S divided by 2. Okay? We now solve for S. We'll multiply each side by 2 in order to get 1/2 S. Then we multiply each side by 2 again, and we get S is equal to 4 times the tangent of 22.5 degrees. Now, that will give us about 1.6 equal to our side. Our perimeter will be equal to our total sides. We have an octagon. It has 8 sides, so it'll be 8 times S. That'll give us about 13.3, okay? So how we do, the area is equal to 1/2 the apothem times the perimeter. Remember, our apothem was 2 in our picture. So it'll be, area will be equal to 1/2 times 2 times 13.3, or our final area of about 13.3. This is problem number 6 done in the book. I have everything listed here. For the sake of time, I'm just going to show the picture. Please let me know if you guys have questions. I know this is a little bit difficult. Follow the steps and you'll be okay. I am more than happy to work on the Zoom Cloud meeting with you in person on this material. Please ask me questions, okay? I look forward to working more with you on this material and hope you guys have a great day.